Okay, good morning. Sorry for the technical difficulties here. Macs don't work. We're going back to the future, I guess. I'm Dave Friedman. I'm a founder and CEO of Ayla Networks. So today I'm here to talk to you about where IoT is headed and some of the things to think about as you design an IoT product. It's kind of hard. I can't. So you know, again, what we believe at Ayla, I sort of always start by saying I'm a history major, not an engineer, and for us, the internet is just expanding. It's kind of started with DARPA, and it expanded. We had IP networking, goes to PCs and mobiles, and really, the internet is now just expanding into things, and Moore's Law is happening to make that happen. Infrastructure as a service is there, and touchscreens. And as the internet evolves into new markets, we know that's this evolutionary force that becomes very disruptive. And so for manufacturers, we think what manufacturing and how you do that and what you do with the data, there will be the haves and have-nots in this market as a result of that. And the guys who figure out how to do it, it's different and it's really hard actually. Ayla does provide a platform for the Internet of Things, and what we find is if you're a manufacturer today, you may be data-driven in your factory, but you're probably not so data-driven in terms of how customers use your products, what features they do. Even warranty and service is all completely fill out the card, send it in, and if you get a call, then that must be a claim. We believe, again, just data transform retail. Amazon is actually just a data company that grabs all your data from your browser, and they give you things that you decide you want to buy for less. For manufacturers, we think there will be, again, the companies who just sell products and they're out there in the field, and the ones who actually have a constant feedback loop. Again, they can do this very well with respect to anonymization and privacy, but a feedback loop of how products are being used for engineering, for marketing, and really building better products. And again, you either figure out how to do it or you're going to be losing to somebody in your market. Now, I'm going a little quick just to catch up on time. So IoT, we believe, requires agility. We'll talk about, it's a theme for us. Actually, we believe maybe if there's one feature, if you're designing something for your own company, is the fact that you have no idea what your customers need. Your end customers or your marketing department, you actually have to be able to create something, whereas if you build a connected product, you can change it fast. You haven't architected yourself into a corner. Building in that kind of flexibility is actually kind of hard, but you don't have a crystal ball. That is maybe one of our key themes in a new market. If you build a connected thermostat today, there might be a question of, well, what features your customers actually care about? You could look at Nest and say, well, maybe the ones they've done. There's a lot of markets where there isn't an early entrant like that, where you don't know the answers, but even still, what are next year's features and how you might want that device to work with other devices, how IT might use the data. You don't actually have those answers, and you have to be able to build in a flexible way, to be agile, to be able to have the feedback loop of learning and then iterating and providing what your customers need, whether your customers are internal or external. Now, I was talking earlier about some of the trends in IoT. This is the good part. Actually, I started in the chip business. Moore's Law is awful when you're in the chip business. It's awesome when you're buying chips. And so adding networking connectivity and putting it in an embedded device might have cost about $8 or so last year for Wi-Fi, and it'll very quickly drop below $5 in 2015. That's neat because a lot of these devices around, the Internet of Things is actually about these lights and all these fire and safety, and they have little 8-bit microcontrollers, so those don't cost a lot either. And so the cost to have networking in something today is dropping dramatically. Similarly, for my company, our biggest supplier has a price war right now, and that's Amazon. Infrastructure as a service, and that's really also thanks to Moore's Law. The cost to have something hosted and managed online, those costs, those per device or per month or however you want to look at it, are dramatically lower today. And so if you're not doing something with it, your competitors probably are. Now, because of that, there's a whole bunch of new devices that are emerging. You can really put networking in almost anything today. Now, it's not so much, we'll talk about, it's not so much so that you have an app. The app, to us, at least for Ayla, is interesting. It's really what you can do with the data. Most products have warranty. A lot of products have warranty. Warranty is insurance. Insurance is all about data, but how many companies that provide warranty and service actually have all the data they need to sort of fit the area under the curve? There's so many hidden dollars in being able to leverage data from getting things connected to the internet that we will start to see. Now, security is critical. We sort of look at this, if you don't do security on a regular basis and have experts who do it, it's hard to do yourself, to pass certificates when a bash bug or something comes up. Do you have the team maybe that can get this done? It is important probably to consider, at least if you're using someone else's software or services or building something yourself, do you actually have the ongoing capabilities to manage that and make it happen? Oftentimes, this is one of those things where you're either a security expert or you're trying to learn about security, and you should refer back to the guy who's the first category. Now, standards are important, and that is to say that you know, the way we view the things at Ayla, again, we follow standards. You use SSL because it's just tested. It's battle tested. You use standard encryption methodologies that are used all throughout the internet. That's probably the best way to go. Proprietary, better encryption, for example, is maybe a little spooky. I think it's something where better is not best. It's sort of whatever the standard is right now is very likely the way to go. And then as new things emerge, and new things like whether it's Thread or Zigbee or those, they should be adopted as they become sort of mainstream and part of what everyone else is using. Finally, again, other IoT trends. Clouds will talk to other clouds. It's critical. You'll create devices, you'll have platforms, but this walled garden will not really be the thing that exists for very long as the Internet of Things expands. There will be, you know, Salesforce does an amazing sort of back-end support set of tools, and so if you build a product, you don't necessarily want to build from scratch your own customer support UI and capabilities. You might want to have your device connected to a cloud and then have that connect to your customer support tools, which are on different clouds. This is just going to be the norm, that very secure capabilities where clouds communicate with other clouds. Now, this is the challenge. You know, if you look at this, it's so easy. Now, at my company, we started as chip guys. We actually were making embedded Wi-Fi. And that, again, awful business to be at a startup. But we learned a lot of interesting things. You can't approach this from the cloud and say, look, I've got an awesome cloud for things. It kind of doesn't work. It misses the point for anyone who makes a thing to say, well, how do I make sure that the thing is connected, and what if I have a different thing and a different? It's very hard actually to do this in a very scalable manner. It's easy to make a prototype and show to other people in a company. It's kind of hard to launch millions of these globally and make them very secure and very scalable. There's so much that needs to get in to a secure and scalable set of connected products. And so this slide, I think they provide with, it's all this stuff. You sort of have to be experts at big data, unstructured data, and security certificates, Ruby, Java, and all of that. It's kind of asking a lot. Typically, a manufacturer today is really good at making what they do. They have the brand, they have the channel, they understand their end users very well. This type of technology is typically something that, if you don't have it in-house, this is a giant stumbling block to this great promise of the Internet of Things. And this is, I think, for me, this slide is maybe the most important of the Internet of Things. This is what must be solved. It's really interesting. The Internet of People is connecting massive OS. It is the biggest difference really between the markets is you can have billions of Linux things, billions of Android and iOS and Windows. And so if you think of all the network things you all have in your home and your friends and family, it's probably one of those operating systems. It's your set-top box, it's your phones, it's your laptops, and so you create plugins and those things go to all sorts of different services. The Internet of Things is the exact opposite, is massive, massive fragmentation. There is no OS really. All things are different. There's probably 100,000 or more different part numbers of microcontrollers that go in things, and none of them have operating systems, or very few do. So, and if you're building things, they all show data in a different way. You can't really tell all thermostats to look the same. It really doesn't work. It prevents innovation, or light switches, or whatever. So data's different, device architectures are different, and again, you actually have no clue what features your customers will want this year or next year. It's tricky. This is probably one of the hardest things. If you can't solve this, you can build a prototype, but you end up building something that serves what you maybe want this year and next year and not what you need to scale. Future-proofing for the Internet of Things is actually the hardest part of the market. Now, we have, I think this one is the only one where we have some logos because we couldn't get things out there. But when we attack the problem, this is why I think, again, with or without our company, platforms will exist in this market. It is just an inevitability, is that there's too much expertise required to really do this well and provide all this future-proofing. You know, at our company, our lead architect was a lead architect at Amazon building the Kindle. Now, we think about it, there were all these ebook readers and then the Kindle, but why is that? Why, and the iPod Touch, why did those products become sort of Kleenex in those categories? It is because they actually have this architecture. They have software in all parts that work together. Now, whether you put a water heater or a boiler or a light switch there, the neat part is that you can make a change in the cloud and you know it'll work with the device. You can make a change on the application and you continue to sort of know that you have this capability to everything continue to work. Now, the Internet of Things then really is interesting because of the word, well, we talked about things. Things are very fragmented. Now it's the internet. And so you're moving away from smart gateways, which is not the internet. It's a smart gateway to smart cloud. The Internet of Things really is now focused on the internet of servers being able to provide all the capabilities that you want in a thing. And what we believe is, it's just simple. It's that a device is changing. The concept and the definition of a thing, if you're a product manager today, is just going to be different. It is the thing and its virtual replica, which is really a superset. It does more. It can connect to weather. This is the thing that connects to all the other clouds. This virtual device stores all the data. Now, you might ask, why do I need all the data? The answer is because you do. You don't know why, but you do. Now, at my company, we don't charge for data at all. We just store. We think it's counter to where we believe the world is. You may have a thermostat and you just want to copy nest. You want to get something out there, but you're going to want to learn. You're going to want to regress why things are not working, what's going on with the HVAC system, and so on. These virtual devices is just going to be the way of the future, and these connect to other clouds. Again, this thing can connect to Salesforce. It can connect up to another channel partner, a retail cloud. It can do HomeKit. You know, this, we believe, is sort of where the world is headed. Now, being able to provide analytics and reporting is the other part that companies will want to do. They'll want to understand what features are being used and why. And now think about that. How many companies that make things today know anything about how the product's being used in the field after they sell it? I mean, close to zero. We have, again, for a thermostat customer, they have a 6-zone thermostat. And you can tell it's one of the most complex features there. And we say, how many of your customers use it? The different zones, they have no idea. Now, it just may be interesting to know. Maybe they create different products from that. I couldn't even explain why all this would be important. The fact is the data will be important, and data science will start to understand and focus on sort of how to leverage that in the best way in each particular category. Let me just check here. We're doing pretty good. So security is important. Like I said, I mean, the way we do things, everything is encrypted. There's no unencrypted handshakes. We do local area network communications for what you do in the local area network. But again, you need to do this. You don't want to be that security breach. You don't want to be that hole in there. And honestly, it is critical to do this the right way. And whether you use a platform or build yourself, the way you manage certificates and keys, it just has to be the way that the security experts would sort of bless and say you're good to go that way. Other elements here that are important as you consider products are something called role-based access control. It is the ability to assign different rights and access based on time and roles for each data point. Now, again, a thermostat may, or a water boiler or something may create 200 different data points, but not everyone cares about all that data. There may be a lot of customers and sell things through distribution. The products aren't sold directly to end customers. The distributor might get some information. The service provider might get information. You might want to give 48-hour access to someone who's doing service and then remove that. Those types of capabilities for security are critical. So wrapping up here, these are sort of I think the keys as one considers what you would do for Internet of Things. Again, what we believe is you have to be able to launch products quickly and you have to be able to learn and iterate. To do that, you have to build in a feedback loop. Now, you can do it without it, and you'll just wonder why your competitor is sort of out innovating you in the market. The expertise needs to be there in the organization. It's not something that you build. Again, it's very easy to build a one-off product. It's very different to build it scalable, to sell it in South America and North America and China and Europe. That is a challenge. You have to know security. You can't fake it. And if you really do this well and you have a platform that allows you to scale, you can launch a lot of products, and you're leveraging the same software, the same code, the same databases, and that is really sort of the path towards sort of scaling into the future. Wow, there we go, high speed. Thanks. Yeah.
On slide 11, when you show security, we don't want security at the end of the sensor level as well. And if the sensor does get infected, what
So our view is we, at least at our company, we enable IP endpoints. And so a sensor, if it's got Wi-Fi in it, there's full SSL encryption down at the endpoint. And so, yes. Again, that device, there's a public key, private key connected to the cloud. There's PKI authentication back down. Each device is uniquely authenticated to have the rights to speak to the cloud and speak to the service. And so, you know, I'm not the security expert. Actually, Cisco's an investor in our company for the purpose where we could say, look, they vetted it, and my security experts also have actually former Cisco people.
So what about sensors that don't have the ability to have SSH or SSL running on chip?
You know, it's an interesting thing. So the way we do what we do at my company to make this all scale, the biggest challenge is how can you do this at scale is we get our software embedded into the chips themselves. Actually, there's much more horsepower on networking. Again, in the case of Wi-Fi here, there's a huge amount of power inside that versus that tiny little 8-bit, which absolutely has no capability to do that. And so we, in a way, create modems out of the chips and the networking chips that go in there. Now, if it's using Zigbee or something, we're leveraging it in the Linux. There is always then a smart gateway. And otherwise, by the way, you'll start to see NFC is going to be really interesting in this market too. Again, it's very secure, but you don't actually have to, you can use, the phone is the backhaul. It is the IP endpoint that then leverages and connects to data where you're not even talking, you know, $5 a bill of materials, you're talking something much less.
So in your school, in order to customize access from the cloud, what are the minimum set of
It's nice. The way we do it is that by putting all our software in Broadcom chips and Marvell chips and Qualcomm chips, then you can have a PIC 18. You can have an 8-bit micro on the other side. Now those modules, those Wi-Fi modules, for example, if that were the how you would approach this, are getting sub $5 now. Now, if you use 433 or Zigbee or Z-Wave or whatever, then you're in a gateway. You're going to a gateway, and you know the gateways can be pretty low cost as well. But the system, it's critical. You shouldn't be forced to use Linux in the system or any OS, and you should be able, and there's billions of 8-bit micros for a reason, because they're perfectly fit for sensing like motion.
Well, what about 6 low band? which is already IPv6.
Yeah, I think so. So, 6 low pan is fine too. Again, the standard. Now the way we do it, but it's not really any different. Is still to enable the gateway, and then have the gateway speak to each node in the local area network. But that's not to say that's the only way, or maybe even the best way. It's just we think if you must have a smart gateway in this business, it's not a good idea. Now, if you happen to have one, then you can leverage. It's a giant system architecture problem, right? If it happens to be there, you can move intelligence into the gateway. What?
I can understand that in greenfield deployments, this architecture already have the chemical but in the interim, you find all sorts of architectures perhaps even have to
Interface with a what?
with a smart user.
Yeah, no, it's fine. Again, now what we find is a lot of our emerging customers already have devices that are connected, and they happen to be gateways or office equipment that run Linux. And so it's downloading a Linux theme, and that now really what the capability to take unstructured data and pull whatever you want out of that thing, add sort of the capability down to the device, and then if you look at that virtual device is now this powerful collections tool for that thing may already have Ethernet, for example, connected. I'm not sure how I'm supposed to be doing on time here, because I think you are right, Max. But I'll stand outside. Yeah. Right? Okay. Thank you.